Here we go. I would love to see the buttons. Nice. Lovely.
And then my bracelet says women's rights equals human rights.
Now we're on. All right, let's take a look at these vector problems. What do we do to be able to try and solve this one? We got to have the same base. In order to be able to solve it, you got to have the same base. So how can I rewrite this base so that we have the same base? Yeah, I can rewrite 9 as 3 squared. That means the same thing. Everything else will stay the same. So we have our 3 squared to the power of x plus 1 and our 3 to the x plus 6. What can I do from here? Yes, we need to get our 3 squared out of its parentheses, which means I need to take my power to this power. So I can write this as my 3 to the x plus 6 equals my 3 to the 2 times x plus 1. You can multiply those two pieces together. Then what can we do? Yeah. I need to distribute this too. What else can I do at this point? Yeah, now that I have those same bases and nobody's inside parentheses anymore, we can just like drop the 3's. We're just looking at the, yay, it froze.
Oh, how fun.
Told you, they're just like not being super friends. Here we go. We can look at just our exponents since they're equal to each other now. So we want to know when x plus 6 actually equals, and we're going to do that distribution, our 2x plus 2. What do we do here? We can subtract the 2. That'll give us x plus 4 equals 2x. And minus x from both sides. What do we get?
4 equals x.
4 equals x. Oh, what that equals.
Or what sounds better in my brain, x equals x.
Agreed, but both are correct.
Like, I legit wrote x equals x.
Yeah, totally fine. 100% okay. Absolutely valid. Questions on that one? Because that's what we did yesterday. Very similar vibe on the right. How can we change the one on the right so that they match up so that we can work through stuff?
2 cubed.
Yeah. Ooh, that's not a pen. There we go. My 8 I could rewrite as 2 cubed because 2 cubed equals 8. It means the same thing. So if we have that 2 to the 3x equals 2 to the 3rd, what are we going to do next? 3x equals 3. So what does x equal? X equals 1. That was a pretty short one. Questions on either of these? Okay, we're going to be going back into our kind of story-based problems. They're very much real life based. And we're going to be getting another equation, another form for our exponential pieces. It's really only adding one letter, but we're going to talk through all of them again. So it's going to be something like this. Oh, and it's directly underneath the close button, so I will write it underneath. So we're going to be working with something called compound interest.
I don't like this.
So I'm going to cover this up for a second because I'm going to rewrite it where it's not directly underneath the close button up here. So our compound interest formula is usually given to us as A equals P parentheses 1 plus or minus R over N to the power NT. We've so far worked with our y equals A 1 plus or minus R to the T, and our y equals A B X. So those are the equations we've worked with so far. And a lot of these pieces mean the exact same thing. It's just that they have a slightly different label because this is almost exclusively used in money, in banking. So it uses some banking specific terms that mean the exact same thing as we've been using for all the others. So our principal value, our starting amount, is what the little a was. So it's this guy. It's our starting amount, what we start with. Like we'd normally start with 5 fruit flies or $2,000 that we put into the account. That's the same piece. Our R as a decimal, same guy. Still this piece. This time it's just in the numerator. T is our time and it's our exponent. We've had that before. The only pieces that are really different is they put A, like a capital A, as the ending amount. You can 100% put it as a Y. Totally fine. It's just our formula has an A in it up here. It's just the ending amount, the amount in the bank account. And the last piece is kind of a weird piece. So this is the new piece. It's this N. And what this N is called the compounding factor. And that's a piece of information that we will give you. So it's a part of the problem. And it'll be something like compounded quarterly. Well, a quarter happens 4 times in a year. So N would be 4. Or it would be compounding weekly. And we'd figure out how many weeks in a year. So it would be 52. So it's going to be like a piece of information that's in our equation.
Tell me why when you said that, in my brain, I thought there was 25 weeks instead of 52.
There's not 25 weeks.
I know it's 52, but my brain went to 25.
It happens. Okay, so these are some important pieces. These are equations that we have that we're going to be working with. So we're going to be working with the top guy, working with that N. And I'll show you what these problems look like. Get these written down if you do not have them down yet. What's up? You should have these guys, but you'll want to write this one down if you don't. But this is the one we did on the very, very first day. This is the one we did Friday, because yesterday we did solving stuff. So now today we're going to work with this guy.
Are we going to get papers to do?
No, we only have 3 problems. And they're like a sentence. So, what's up? Yes, this is our plus or minus R to the T.
To the T.
To the T. It could also be to the X. X, as I say, I think we did mostly do it with X. I'll switch it. Boop. X, but it's still being that unit of time. Whenever we calculated something, that's what always wound up being our unit of time. Just since compound interest, I genuinely cannot think of a time it's not used on money. Tends to get these very banking specific terms. Principal, like this, just means the amount of money you put in. It's the starting amount of money. Like you'll hear people, when they start talking about buying a house, the principal that they put down for their mortgage. It's just their payment that they paid when they bought it.
Speaking of banks, my mom works at Merchants Bank.
Nice.
And you know how in the commercials they have the frog and then the president of Merchants Bank?
Totally.
I actually met the guy.
Nice.
Yeah.
I've never seen that commercial.
I'll show you.
That's okay. All right, so we will be given problems like this a lot of times. So here we've got that Celeste has $1,000 in a savings account. and she's going to earn 4% interest. We are asked to calculate her balance after 18 years if it's compounded annually versus if it's compounded monthly. So, yeah. There we go. Sorry, trying to. So I'm going to write the kind of basic equation over here, our form. That's our A equals P1 plus or minus R over N to the NT. So what pieces do we know here for this equation?
Our starting point is 1,000.
That starting amount. That's going to be our principal balance. That's that P. Thank you, dear. So we're working with our principal balance of 1,000. What else do we know? The 4% definitely going to have something to do with our rate. How are we going to write that R? Got to put it as a decimal, so what's it going to be? 0.04 or 0.04. Either way is fine. So now we've got our R. One more piece from that top paragraph. Yeah, our time's going to be 18 years. So kind of our starter equation on this one, before we get down to the compound part, that's when we have our P of 1,000. Is her account going to grow or is it going to decay?
Grow.
How do we know grow? Earns. So are we going to use the plus or the minus? Plus. So we've got our R, which was our 0.04. And we're going to have something times our 18 up here. So our last piece we need to figure out is going to be our N. So what we're looking at is how many times these happen per year, because we're looking at years here. So honestly, I think it's going to be easier to start at the bottom. How many months are there in a year? 12. So what that tells me is for this one down here, when we're talking about monthly compounding, our N is going to be 12. Does anyone know what annually means? How many times per year something annual happens? It's a really weird way to word it because annually means once every year. It happens once a year. So our N on this one was actually going to be 1.
Like how birthdays.
Birthdays are an annual event. Yes. So on the first equation, our N's going to be 1, and we're going to accidentally ourselves into the exact equation from yesterday, or Friday. Because when we have our annual value of 1, we get our A equals our 1,000. 1 plus our fraction. It has our 0.04 over 1 to the power of 1 times 18. This is our N, and this is our same N. The same N goes in both spots. So we're substituting those pieces in, and then we are going to come through and simplify this. I want you to simplify what's inside the parentheses. And even when we have kind of ucky things in here, we can type just this statement into the calculator, the 1 plus the fraction 0.04 over 1. So our simplified version of the equation is going to be our 1,000. What do we get when we simplify our 1 plus 0.04 over 1? 1.04. And then what's our exponent? 1 times 18. 18.
I don't know why I said that.
It's okay, you're playing with accents. It's all good.
18, you put that in the exponent.
Mm-hmm. So the exponent needs to be the n, so that same thing we divide by here, times that unit of time. So since it was 1 times 18 is why we get the 18 on there. So what do we get as our value for her bank account, our 1,000 times 1.04 to the power of 18? What do we get? How much is in her bank account?
20.5.
Oh,
I would say 0.82.
2025.82. Yes, because it's money, we need to round it to 2 decimal places. I'm just fixing that 5 because that 5 looked weird. Ah! Fixed it a little too aggressively and it went away. So then let's look at the difference between doing it annually versus calculating this monthly. So the only thing that's going to change between this equation and the one we write down here, it's still Celeste with her same principal, her same rate, and her same time. The only thing that's changing is she picks a different bank that will compound it monthly. So the thing that changes, we're going to have our A equals same $1,000, the same 1 plus our fraction with our 0.04, but this time it's going to be over 12.
I know like this.
And our exponent, it's not going to be 18 anymore, it's going to be 12 times 18. Because what this is that the bank is not taking your account over the whole year and giving you one payment of interest. Every month, they're calculating a little bit of the interest. So you get a little bit in January, and then you get a little bit in February, and then you get a little bit in March, and a little bit in April. So they take our full year interest and they cut it into teeny tiny pieces, and they give you just a little bit of it.
I don't like the decimal that I did.
Mm-hmm. It's entirely possible.
The decimal that I at least got
Mm-hmm.
is 11.003 repeating.
Mm-hmm. Yes. So we do get a very long kind of icky decimal. So when we are doing these calculations, and especially on these ones that have ends, we may need to put it in like this actually in the calculator when we type it out. I still like for us to simplify it so we can see how this is growing. It is growing by a very, very, very small amount. 1.0033333. That's a 3. 3, blah, blah, blah. Repeating. To the, what's our power?
216.
Mm-hmm. So if you do not want to have to type things in as fractions into the equation, you can order of operations it yourself and do it on the calculator in separate steps, or you can type it all in one go. I'm going to open up the calculator so I can do some of it up here on the screen for us. Give me a second for the calculator to load. This is it. There we go. So looking at our calculator, you can type this in a couple of ways. It's going to complain at us for a second because I'm going to turn the touchscreen back on. I know. So you can either come through and we can straight up do it exactly as it's written in the equation. Oops, there we go. Our 1 plus our fraction that has our 0.04 over 12 to the power of 12 times 18. We can straight up type it in like this. That totally works. It is unpleasant and scrolly, but it is there. It will spit out an answer. Or we can do it separately in separate chunks, simplifying our parentheses and doing things that way. Where I take my 1 plus my fraction, 0.04 over 12, to get that 1.00333 repeating. And then I raise this piece to the power, because the next piece that comes is my exponent, to the power of, that was our 216, right?
Mm-hmm.
And then our last piece was to multiply it by our 1,000. And it should be pretty darn on close to what we got by typing it in one go. So you can do it either way, typing it in to the calculator, and we should get the same answer, which is going to be that this time she would have $2,051.97. $2,051.97. What do we notice about her balance? About how much money she gets? She gets more. Even though we took our interest rate and cut it into teeny tiny little baby pieces, she still get more money because they calculate interest on the interest. As she earns more interest, those little baby bits are growing too.
Couldn't you round that up to 98?
Nope, I was not even paying attention to the rounding. I was caught up in the...
The decimal is 974,828.
So when we're going for two decimal places, we go right there. So the 4 does not push us up. 4 keeps us where it is.
Okay, I was thinking that 8 makes the 4 a 5.
If we go far enough down that line, we're going to start rounding everybody up.
Good.
So, nope, just take the 1 next to it. Okay, so this is what we're looking at with these kinds of equations. They don't really get worse. They just get more examples. So we're going to practice again. I'm going to give us a new setup. So we've got Jadion with a savings account of $10,000. This time he's got a really terrible credit rating, and he has an account that charges a fee of 1% a year. So then we're calculating his balance compounding monthly, compounding daily. So we're still using our same equations, our same structure at least, that A equals P times R1 plus or minus R over N to the NT. We will give you these formulas, but we will not label them, nor will we tell you what any of the letters mean. But we'll have them all up at the top of the test when it comes time for that. So what pieces do we know? The starting point. Our principal. Yep, what's our principal? The $10,000. That's what he's starting with. The rate is 0.01. Exactly right. I just realized this doesn't actually specify a T.
It would be subtraction because it's charging a fee.
It is subtraction because it's charging a fee. And then I didn't specify a T on here, so let's go with a time of 5 years. So I'm just going to tell us that T equals 5 because there's not one actually on here. Huh? I mean, yeah, I'm saying time is 5 because there's not one on here. There should be, but there's not.
And numbers can get too big.
So we've got a lot of the pieces here. I've got my T, I've got my R, I've got my P. For monthly, what's my N going to be?
12.
12. How about for daily?
Is
you can assume non-leap year unless specified. So how many days in a year typically? 365. I mean, if we're feeling really petty, you can do 365.25, but we're not. So we're gonna fill in our pieces here. So our amount in the account is our $10,000. Our 1 minus our fraction that has our 0.01. And in this case, we're over that 12 to our exponent of that 12 times 5. On the compoundings, you will very rarely like it. They're always going to be a little bit gross. The rest of them should always come out at least being not brutal, but the compoundings, they're going to be brutal. They just are. They're icky. It's just the way they work. So, the one thing I want us to see when it comes to the simplifying on there is that when we do that 1 minus our fraction of the 0.01 over 12, we get a number that is less than 1. This is a decay. It's a very slight decay because we're at 0.9916666, but it is decaying. It's getting smaller and smaller and smaller, just very slowly. So what are we going to get for his balance after 5 years? What is left in his account? Get all the way to our answer. Because most of these are, once we write the equation, type it in the calculator. Mm-hmm. Mm-hmm. Let's see. It just depends on where your rounding is. Let me see if it...
I mean, I don't trust my rounding anymore.
Okay, so I'll put it up on the screen just so we can look at it. Because, yes, we should get our 9512 point, it should be 095. So if I do this on the calculator here so we can see it, our 10,000, make sure we get enough zeros because I did that at one point wrong. Our 1 minus our fraction that has our 0.01 over 12 raised to the power of 12 times 5, we get 9512.0959. 2 decimal places is where we're rounding. And the 5, is that going to push us up or are we going to stay the same? Pushes it up. So if I have 9 and we're pushing it up, what do we wind up with? Yep, 0.10. We go from 9 cents to 10 cents. The bank would try and round that down most likely because they would like to keep all the money that they can. So the only difference between this monthly and doing this daily is we're going to change that 12 out to be a 365. So it's going to get real big real fast. So everything else stays the same. So when we give you different compounding amounts, everything else stays the same. The only thing that's changing is our n. We still have our 1 minus our fraction that's going to have our 0.01 over our compounding factor, but now that compounding factor is that 365, and this decimal is going to be really, really tiny. It's going to be just barely under 1. But our exponent is going to get really huge as it's 365 times 5. So on these ones where we have these super duper super tiny decimals in the parentheses, it's okay to not write the whole thing out. Like, it's okay. I do want us to do it in the calculator, like how we've been doing it, where we type the whole thing in, either in pieces, in 2 or 3 separate steps, or in one big step. It makes a difference. Bless you. Don't type in rounded off numbers in the middle of the equation. Use the calculator to do the work for you. So, let's do that one with the 365. When you're doing a problem like this where we have the same pieces that we're just changing one piece in there, you can always do our up, up, enter. And go back to switch out my 12 for a 365. Just be careful in our exponent when we switch it to be a 365. We're going to have to then do our times 5 again because it fills in the spot. But then you don't have to type the whole thing again. We like that. And we wind up with almost the same answer. What's different between our 2 settings? Yeah. She got a different amount of change. So this time she's going to wind up with 29 cents. She still got $9,500 and oh, sorry, he has $9,512, but now he's got 28 cents. $9,512.28. Okay. One more. Do it. So now we've got Luna depositing $5,000 into an account that pays 3.9% interest, and we want to know the value in 8 years, compounded quarterly or compounded daily. What pieces do we know about this situation?
Pays means add.
Mm-hmm. Yep, so pays tells us we're going to use the plus.
Our starting value is 5,000.
Our principal, our starting amount is the 5,000.
Time is 8 years.
Our time is 8. One more piece from there.
23.
How many spaces over? So try it again.
And then put 0.
Mm-hmm. That's okay. 0.039. So for both of these situations, we use all those same pieces. Our R on a highlighter is this guy. And then our time was this guy. So for our first one where it says quarterly, what's our N going to be? That's not a pen. What's our N for quarterly? Super close, and a C where you're getting the idea. 4. Think about how many quarters are in a school year. We have 4 quarters. 4 quarters to $1. And then for daily, we've done this one, but what's our N? 365. We could ask you kind of any unit of time. We could do daily, we could do weekly, we could do monthly, we could do annually, we could do semi-annually, any number of things. So we have lots of choices that are going to be there. So our equation is going to start out the same for both of them, where we have our $5,000 substituting in our pieces. We're going to have our 1 plus our fraction with our 0.039 over our N of 4 to our power of 4 times 8. So there's our quarterly equation. Do we get a nice decimal on that one?
Yeah, because 1 plus 0.039 over 4 is 1.00975.
Yep, so that one's not awful.
Thankfully.
So what do we get as our value in the bank account? How much money does she have if it's compounded quarterly?
4,600.
Yes. She will have $6,820.46. What about if instead of compounding quarterly, her bank decides to compound her interest daily? $365. What's going to be different on this one? All the other pieces stay the same. The only thing that's changing is our compounding factor.
I don't know if I like the decimal amount, but so I'm not gonna write it. Because
That's
it's
okay.
so-
Yes. If it's long and unpleasant, don't necessarily put it down. I don't necessarily need to know. I just want us to see it. What is her balance here? Mm-hmm. And 66 cents. So, if they compound our interest more frequently, do we get more money or do we get less money?
More money.
More money. Because if they only give me interest 4 times in a year, she got $10 less at this bank account than she got here. And yeah, it's not much, but if we were talking like millions of dollars, it's like 10 grand. Free money. So, which bank account we use is important. So, I'm going to give out homework number 2.
Ew.
I know. I'm horribly cruel. This is going to include everything we did today, the things we're going to do tomorrow, and the stuff we will do on Friday after SAT, so it's not going to be due until next week. So we can do any of the things that tell us a number for our compounding. So compounding annually, weekly, daily, that kind of stuff. If you see the compounded continuously, which is mostly on the back, but that is something we haven't talked about yet. We will probably get to it tomorrow, but we will probably not finish it until Friday. So, just saying. That is not a thing that you need to figure out. We will talk about it Friday.
Are these actual names of actual President candidates?
What's up?
Are these actual names of the actual, like, president? Presidential candidates?
Yes.
Didn't know that.
I mean, none of them technically won. But, yeah, they were all candidates at one point, but I think most of those were from the 90s. All right, let me get our announcements up.